Okay, so there we have the sun. Here we have the Earth, whose axis is pointing always north. So as the Earth orbits around the sun, the axis will always point north. So it will never look like this. It will always look like that in space. At this point, because it's on this side of the sun, the northern axis, or the axis on the northern hemisphere, is pointing towards the sun as well, not just north, but towards the sun. And obviously we have a lot of daylight here in the northern hemisphere. And so as the Earth rotates, we have a lot of daylight and then short nights. And on top of it, the sun is actually shining down directly onto the Earth's surface here, and a lot of the sunlight is absorbed. It's at a very high, quite high angle, and for those two reasons, we get a lot of energy from the sun here, and that's what we call summer. All right. I'm here kind of in June. I'm not going to go to next year to July, August, and then September. I'm just going to go over to September. Okay, I'm going to orbit this one around the sun here. What I'd like you to do is I'd like you to turn the sun with me, our overhead projector, which I don't call that way. Technically, I should rotate the sun, the Earth here all this time as I do this, right? But I'm not going to do that. So we just imagine it's actually rotating, and then I'm over here, and eventually I'm in September. Notice that the axis is still pointing in towards the north in space, but now, of course, it orbited the sun about 1/4 of an orbit, and now we have here on the northern hemisphere, half the time, 12 hours, it's going to be daylight, and half the time, 12 hours, it's going to be darkness, night. And so we're kind of in between the seasons. Since we came out of summer, we call it, of course, fall. I could make the same arguments for the southern hemisphere, by the way. What did I have for the southern hemisphere over here for a season? I didn't mention it. Winter, and I will explain. I show that later when I get over there, and you will be able to see that. So for them, of course, it would be kind of spring, and so we have 12 hours daylight, 12 hours darkness, night, and we're kind of in between the seasons. Okay, another 3 months later.
Yes.
So again, as I orbit this one around the sun, the axis is always pointing north, but now I'm on the other side of the sun. So it's actually pointing away from the sun, and here is my day. Let's see where Alaska is. There it is. So here's my day in Alaska. The sun rises, and it sets, and it rises again. And we have very short days, very long nights, so we don't get much energy, and the angle, as we're actually tilting away from the sun, the angle towards the sun is very shallow, and so the sunlight and the energy is really spreading out across the surface, and we get very little energy during the winter, and therefore it's getting really cold. And you guys know that looking at the sun's motion, or the sun's apparent motion in the winter, it is really just getting up there in the east and very low above the horizon in the south, and then it sets. Okay, southern hemisphere, by the way, gets a lot of daylight here. Wherever, let's see, here's Argentina and Chile, and here is South Africa, and I'm actually turning the Earth in the wrong direction. So here we go, Australia and New Zealand. And apparently I also glued a Lego figure to New Zealand at some point, so that's why it's peeled off. And you would see that you actually have really long days in Australia during summer. So here the sun rises, and the sun sets, and the sun rises. So really long days at the same time. Not as extreme as Alaska, but that's because Australia is relatively close to the equator as compared to stuff in the northern hemisphere. In fact, if we go to Antarctica, down here, right? Did I talk about the sun rising in Antarctica?
It's a very short day down there.
No, it's a very long day right
Very
now.
long day.
Very long day. In fact, the sun doesn't even rise. It's already above the horizon at all times. But it's a relatively shallow angle, so even though there is 24 hours of daylight down here, at Antarctica, but the sun is really still low in the sky, so that means it actually gets relatively little energy because it spreads out, and that's why it never gets warmed. Well, sometimes I think they have like a 50 or 60 degree Fahrenheit day or so. Okay, 3 months on, again, as I orbit around the sun, the axis in the northern hemisphere is pointing always north. And now again, I'm kind of in this neutral part here where I have 12 hours of daylight and 12 hours of night. And this one here, because I came in the northern hemisphere from winter, I would call spring now. In the southern hemisphere, I would actually call it fall, because they came out of summer. And then I'm back to a year later. And again, the axis is always pointing north, but now I'm on the other side of the sun again. So the northern hemisphere again has summer, because you have long days here, and you have more direct sunlight at a high angle, so it's more concentrated. Overall, I express why we have seasons with four, what do I call it? 4 parts, so to say, that go together. One of them is the axis tilt, always in the same direction. The second one is the orbit as it goes around. So relative to the sun, the axis tilt changes. In space, it's always the same, but relative to the sun, it changes, and you saw that, either towards the sun or on the other side, away from the sun. So those are the first 2. The third one is the amount of daylight you get. So very long days here in the summer, very short ones over there. And the fourth one is how the sun actually shines onto the surface at a very high angle, so it's concentrated here, and on over there on the other side, half a year later, it's actually a shallow angle, and you get relatively little sunlight. Those are the 4 things that combine in order to give us the seasons. And I don't think that was 5 minutes. It probably was close to 10 minutes, right?